Welcome to part 2 of present value and future value concepts. I'm going to be picking up where the previous video left off. We had talked about annuity-immediate in the previous video. This one, my main focus is going to be annuity-due. The difference between annuity-immediate and annuity-due is that with annuity-due, the payments are not at the end of a payment period, but the payments are rather at the beginning. So I'm going to populate my timeline here, just like I did in the previous video. The timeline looks exactly the same so far, but I'm going to put my ones at the beginning of each payment period. And notice where the one place that you do not see a payment is at the very end. Let me clarify this over here, like that. Yes, there is not a 1 at time n, but there is at every other point, including at time 0. And I think I'll do what I did the same last time and start with future value first. So future value, consider that dollar that you have at time 0. It earns interest for n periods. And so at time n, which is where S angle n is evaluated, that first dollar has a value of 1 plus I raised to the n power. So consider the dollar that is at time 1. Well, it earns interest for n minus 1 periods. And on and on and on we can go until eventually, let's look at the dollar at time n minus 2. It only gets 2 years of earning interest. And then the very last payment of $1 at n minus 1 at time n minus 1, it earns interest for 1 year. Now, I'm going to do a little thing where I'm going to reverse the order of all this. I'm going to do it in one quick motion. And I did this so that you could see that this is a geometric series, like the other one was, where the first term in this case is not 1, but 1 plus I. And it happens that it's the same, that the common ratio is also 1 plus I. And so what we have is, we have 1 plus I, let's make that look a little better, 1 plus I times 1 plus I raised to the n minus 1 all over, let me make that into a bracket there, all over 1 plus I minus 1. And a little simplification then yields 1 plus I to the n minus 1 all over I times 1 plus I. And this should look familiar to you. This should look a lot like the S angle n formula, except it is multiplied by a 1 plus I. And this has its own notation for annuity-immediate. It is S double dot, annuity-due, my bad. S double dot angle n is exactly like S angle n, except the payments are at the beginning. And there are several ways to relate these together, which we'll see after a little bit. But first of all, I'm going to move on to the present value formula for annuity-due. This time I'm going to look at present value of annuity-due, which is a double dot angle n. And once again, the payments are at the beginnings of the payment periods. So we have one at 0, but we do not have one at n. So then let's consider $1 at a time. Let's take a look at the dollar that is at time 0. At time 0, its present value is 1. The dollar at time 1, well, it's one that we need to back up the interest by 1 period, which means we need to take 1 plus I to the negative 1. The dollar at time 2 has a present value of 1 plus I to the negative 2. I'll carry over to the next line. The one at n minus 2 has a present value of 1 plus I raised to the negative. And this is kind of easy because if you notice that it's just the negatives of the actual time number. The last one is 1 plus I to the negative n minus 1. Now, I'm going to relate this to the future value in another graphic in just a second. And we will see how the formula comes about. Okay, so here is a parallel comparison of the two. So I've reversed the order of my A double dot angle n, and I've also carried the negatives through on those negative n minus 1s or negative n plus 1s, as the case may be. And what we can see is that let's see, A double dot angle n is the same as S double dot angle n times 1 plus I to the negative n, which means it is the same as 1 plus I to the n minus 1 over I, that's the S, and then times 1 plus I, that's the S double dot formula, and then times 1 plus I to the negative n. Now, I'm going to simplify this a little bit. I'm not going to multiply the 1 plus I through. I'm going to multiply the 1 plus I to the negative n through. So when I do that, I'm going to get 1 plus I to the negative n times 1 plus I to the n is 1, and I get 1 minus 1 plus I to the negative n over I times 1 plus I. In other words, A angle n times 1 plus I. Now, I'm going to show a few parallel situations now. So what we have so far, at least, is that to get the double dot A angle n or S angle n, we just multiply by 1 plus I. Okay, so that's one equivalency. It's one important equivalency. And we've also seen what the long forms look like. Now I want to show another equivalency, and I'm going to do this with the help of my timeline. This is what they call the now you see it, now you don't approach. So the payments are, again, at the beginning of each period. So consider, first of all, S double dot angle n. Okay, S double dot angle n. Well, one significant difference here is that we have, if we look at S double dot angle n, that's the value at this point, at time n. We don't have a payment there. With S angle n, we would have a payment there. Well, suppose then that we do put a payment there. Let's put this in red. Let's say we do put a payment there. Well, this time we have a future value. And the future value, though, is of not n payments, but of n plus 1 payments. So that is exactly the same. So if that red one were there, then that is exactly what the value would be, except we don't have that red one there. So we need to subtract it. Well, its value is 1 at that time. So in order to subtract it, we just remove that 1, and we then make a minus 1 there. So that is another equivalency to S double dot angle n, is S angle n plus 1 minus 1. Now let's consider the case of a double dot angle n and try and use the now you see it, now you don't method. So we're looking for the value for a double dot angle n is the value there at time 0. Okay, well, what we need to do then, what we can do is take, well, that 1 that's at time 0, that would normally not be there. If we had a present value of an annuity immediate, that 1 at time 0 would not be there. So suppose it's not there. So I'll very carefully erase this 1 that's here. And now I have n minus 1 payments. So I have a angle n minus 1. Except that payment of $1 really is supposed to be there. So what I need to do is put it there, and its value at time 1 is 1. So I need to add that 1 in. And that is another equivalency that we have. So hopefully this makes a little bit more sense, and you, if you need to, go back to any part of this that you need to go back to, and make sure that you understand all these concepts. And I think that's all that we have time for today. Thank you.